In this video, we will discuss how to find the number of trailing zero. Now, trailing zeros are the zeros which come at the end of any number. For example, suppose the number is 2000. So, in this particular number, these three digits, these three zeros are the trailing zeros. Now, for example, we have a number 1050300. So, these two zeros, we won't count these two zeros in trailing zeros. The number of trailing zeros in this number is 2. The zeros that are coming at the last, right? So, what is the concept behind finding the number of trailing zeros? We know that for having zero in any number, for having any trailing zero in any number, we must have a pair of 2 and 5. Why? Because the prime factors of 10 are 2 and 5. So, whenever we have a pair of 2 and 5, we'll get a 0 at the end of the number. So, suppose we have a number in which there are 4 2's and 3 5's. Right. So basically this number is 16 into 125. Right. 16 into 125, which is 2000. So we are talking about 2000. Now we need to check how many trailing zeros are there in this number. So we'll check for the pair of 2 and 5. Here we are having 3 2's, in fact 4 2's and 3 5's. So we can have at max 3 pairs of 2 and 5. Right? Although we are having an extra 2, but we don't have any extra 5 to pair with it, right? So the number of pairs that we have is 3 pairs. We are having 3 2's and 3 5's. So we will have 3 pairs, right? So this is the concept behind the number of trailing zeros in any number. Now, what are the different type of questions? Suppose we are given a question, we need to check the number of trailing zeros in the multiplication of this number, 45 into 25 into 18 into 14. Now we simply check for the number of 5's and 2's. Now in 45, the prime factors of 45 are 5 and 9. That of 25 are 5 and 5. Prime factors of 18 are 2 into 3 into 3. That of 14 are 2 into 7. Basically we are not interested in any of the digits other than 5 and 2. So in total we have 3 5's and 1 2 2 2's. So in total we will have 2 pairs of 2 and 5. So at the end of this number we will be having 2 zeros. Right? Since we were having extra number of 5's, but then we don't have any extra 2 to pair with it. So we will have 2 zeros in this particular number. Going to next question. Now here we can see that in 45 we have 1 5, in 55 also we have 1 5. We are not concerned with the other factors. We are only concerned with 5 and 2. In 65 also we have 1 5. In 75 we have 2 5's. That is 25 into 3 is 75. So we have 2 5. 85 again 1 5 and then 95 again 1 5. So we have this much number of 5. 1, 2, 3, 4, 5, 6, 7. We have 7 5's. But then we don't have any 2 to pair with it. So in this particular number, we will have 0 zeros at the end. So we don't have any 0 in this particular number at the end, right? We need to find the number of trailing zeros in 22 into 33 into 44 into 14 into 63. Now, for finding the number of trailing zeros, we need to look for number of 2s and number of 5. Now we also know that any multiple of 5 will either end in 5 or will end in 0. Now here we don't have any number ending in 5 or 0. So we may have number of multiple of 2's present over here, but since we don't have any multiple of 5, so there won't be any pair, right? Why? Because we are having 2's but we don't have any 5. So there won't be any pair. So the number of trailing zeros would be 0 in this particular case. Moving to next part. Number of trailing zeros in 5 factorial. Now we know that 5 factorial is 5 into 4 into 3 into 2 into 1. So let us check for the number of 5. The number of 5 we have 1 5 only. Number of 2's we have 1 2 from here and 2 2's from here. So we have 3 2's whereas we have 1 5 only. Now this is the limiting factor because this only will decide how many pairs can we have. So basically we need to look for the limiting factor, right? So we can have only one pair. So the number of 0 at the end of this 5 factorial is 1 only, and we can see 5 factorial is 120. We have only one pair of 1 0 at the end of this number, right? Moving to next part, 20 factorial. Now this 20 factorial is 20 into 19 into 18 and so on till 1. Now it would really be complicated if we calculate the number of 2s and 5 manually. Like in 20 we have 2 2s and 1 5 and so on. So this will be very difficult. So for doing such questions, what we do is we simply divide this 20 by 2. Now this number will give us the numbers that are having only 1 2 in them. For example, 2 is such number, 6, the 6 is 2 into 3. Then we have 10, this 10 is 2 into 5. So on dividing the 20 by 2, we have got the number of numbers that are having only 1 2 in them. Then to check for the numbers which are having more than 1 2, that are 2 2s in them, we'll divide this number by 2 square. That is 20 divided by 4, that is 5. So we are having 5 numbers. For example, we have 4. So in 4 we have 2 2s, right? So there are other such numbers as well. So there are 5 such numbers which are having 2 2s. Then we'll divide this 20 by 2 raised to power 3, that is 8, to check for the numbers having 3 2s in them. So basically we need to look for quotient over here. We need not to worry about the remainder. So 20 on dividing by 8, the quotient would be 2. So there are 2 numbers which are having 3 2s in them, and the numbers are 8. This 8 is 2 into 2 into 2. So we are having 3 2s in 8, and then 16 also, right? Now let us divide this 20 by 2 raised to power 4, that is 16. So on 20 on dividing by 16, the quotient would be 1. So we have one number which is having 4 2s in it, and the number is 16. 16 is 2 into 2 into 2 into 2, right? So in total, the number of 2s that we have got is 10 plus 5 plus 2 plus 1, that is 18 2s. Now let us check for the number of 5. Now 20 when divided by 5 will give us 4. So we have 4 numbers that contain 1 5 only. The numbers are 5, 10, 15 and 20. All the multiples of 5. Then on dividing 20 by 5 squared, it is 25. Now since the quotient here would be 0, so we don't have any number which contains 2 5 or more than that, right? So we have 4 5s and we have 18 2s. So the pair that we can make over here is 4 pairs only. So this 20 factorial will end in 4 trailing zeros, right? Now one thing is logical over here. We need not to check for number of 2s. Why? Because the number of 2s always would be greater than the number of 5s. Since every second number is multiple of 2 and every fifth number is multiple of 5. So we always know that the number of 2s is always more than number of 5 in any factorial. So we need not to worry about the number of 2s. We will check for number of 5 only, as that would be the limiting factor. Now going to next example. Now in 25 factorial, now we will not check for the number of 2s. We will check for the number of 5s only. On dividing it by 5, we will get 5. So their quotient is 5. So there are 5 numbers which are 5, 10, 15, 20 and 25 which are having single 5 in them, right? Now we will divide this 25 by 5 square. Now this will give us the number of numbers having more than 1 5, that is 2 5s in them. So this is 1, quotient is 1, 25 divided by 25 is 1, right? So this is the only number having more than 1 5. This is 5 into 5. Now we'll divide 25 by 5 cube. Now since this 5 cube is 125 and the numerator is less than denominator, the quotient would be 0. Quotient would be 0. So we don't have any number having more than 2 5. The number of 5s that we have got is 6. And we know that the number of 2s in 25 factorial would be quite more than this number. So the limiting factor would be number of 5s only. So we can have 6 pairs of 2 and 5. So at the end of this 25 factorial, we'll have 6 trailing zeros, right? Now let us move to the next part, 100 factorial. So we'll follow the same process. We'll divide this 100 by 5. We'll get 20. So there are 20 numbers which are 5, 10, 15, 20 and so on, which are multiple of 5 and have only 1 5 in them. Now we'll divide this 20 by 5 square. So that is 100 by 25, that is 4. So we are having 4 numbers which have more than 1 5, or we can say 2 5s in them. And the numbers are 25. This is 5 into 5. Then 50, which is 5 into 5 into 2. Then 75, which is 5 into 5 into 3. And then 100 itself, which is 5 into 5 into 4. So there were 4 such numbers having more than one 5 in them. Then we'll divide this 100 by 5 cube. Now this 5 cube, since this is more than 100, the numerator is less than 125. So the quotient over here would be 0. So we don't have any number which is having more than 2 5 in them. So the total number of 5 that we have got is 20 plus 4 is 24. Now we know that the number of zeros in this 2 factorial, 100 factorial would be quite more than this. So this is a limiting factor. So this will decide the number of pairs that we can make, and the number of pairs is 24. 24 pairs of 2 and 5. So the number of trailing zeros at the end of this number would be 100 factorial would be 24 only. Moving to next part. 250 factorial. Again we will check for the factors multiples of 5 only. We need not to worry about number of 2s, as that would be quite more than number of 5s. So this will give us 50. So there are 50 numbers which are having a single 5 in them. Then we will divide this 250 by 5 square. That is 125. So this will give us, sorry, there is 25. So this will give us 10. There are 10 such numbers having 2 5s in them. And we will divide this 250 by 5 cube, that is 125. So there are 2 such numbers having 3 5s in them, and the number are 125 itself, that is 5 cube, and 250, that is 5 cube into 2. So these are the 2 numbers having 3 5s in them. Now 250 divided by 5 raised to power 4, that is 625. Now since the remainder, the quotient over here would be 0, since this numerator is less than denominator, so we don't have any such number which contain more than 3 5 in this 250 factorial. So let us calculate the total number of 5s. So we have 50 plus 10 plus 2. So in total we have 62 5. So we will have 62 pairs of 2 and 5. So the number of trailing zeros at the end of this number 250 factorial would be 62. Next example, 900 factorial. Again we will follow the same process. 900 divided by 5. So this will give us 180. So there are 180 numbers having single 5 in them. Then we'll divide this 900 by 5 square. That is 900 divided by 25. So this is 36. There are 36 numbers which are having 2 5s in them. Then we'll divide 900 by this 125. Right? So in 7 times it will give us 875. So there are 7 numbers which contains 3 5. Then we'll divide this 900 by 5 raised to power 4, that is 625. Now this will go, the division would be for only one time. So we are having one number only which contain 4 5s. Now when we divide this 900 by 5 raised to power 5, so the numerator would be less than denominator. So from here onwards we won't be having any number which is having more than 4 5s in them. Quotient over here is 0. So our total number of 5s that we have is 180 plus 36 plus 7 plus 1. So in total we have, let's get 2 and 124 zeros at the end of this 900 factorial. I hope you must have understand this concept. Thank you so much.